The reactivity of metals differs from one metal to another. The form in which a metal occurs in nature depends on its reactivity. Gold has very low reactivity and therefore can be found in its metallic state in nature. Aluminium, potassium, and sodium have very high reactivity and therefore exist as compounds in nature. One of the common compounds formed by metal is metal oxide. The formation of metal oxide is a redox reaction. When metal reacts with oxygen, it will produce metal oxide. In the formation of metal oxide, metals undergo oxidation to form positive ions. Its oxidation number increases from 0 to a positive value. Oxygen undergoes reduction to form oxide ions. Its oxidation number decreases from 0 to -2. Metal act as the reducing agent while oxygen gas act as the oxidizing agent in the formation of metal oxide. The more reactive a metal is toward oxygen, the more vigorously it burns in oxygen. By observing how vigorously the metal react with oxygen, we can arrange the metals according to their reactivity towards the oxygen. In the experiment, when solid potassium manganate 7 is heated, it decomposes to give out oxygen. Other solid that can replace the potassium manganate 7 is by heating a mixture of potassium chlorate 5 with manganate 4 oxide as a catalyst. It will produce oxygen gas. Another one by heating potassium nitrate. Also, it will produce oxygen gas. The glass wool in the experiment separate the metal powder from the solid potassium manganate 7. If the substances are mixed, the mixture of metal powder and solid potassium manganate 7 will explode when heated. The reactivity series of metals toward oxygen is a list of metals according to their reactivity with oxygen. This series of metals is quite similar to the electrochemical series because the reactivity of a metal with oxygen is closely linked to its ability to lose electrons. Position of carbon in the reactivity series of metals toward oxygen. The position of carbon in the series can be determined based on the ability of carbon to remove oxygen from metal oxide. Another one, the ability of metals to remove oxygen from carbon dioxide. Based on the ability of carbon to remove oxygen from metal oxide, carbon is strongly heated with a metal oxide. If carbon is more reactive than the metal, it can remove oxygen from the metal oxide. In other words, carbon can reduce the metal oxide to metal. We can make the conclusion the carbon is positioned between aluminum and zinc in the reactivity series of metals toward oxygen. Based on the ability of metals to remove oxygen from carbon dioxide, a heated metal is placed in carbon dioxide. If the metal is more reactive than carbon, the metal can remove oxygen from carbon dioxide. The metal can reduce carbon dioxide to carbon. If the metal is less reactive than carbon, it is unable to remove oxygen from carbon dioxide. Position of hydrogen in the reactivity series of metals toward oxygen. We can determine the position of hydrogen in the series based on the ability of hydrogen to remove oxygen from metal oxide. In this experiment, a metal oxide is heated in the presence of hydrogen. So, if hydrogen is more reactive than the metal, hydrogen is able to remove the oxygen from the metal oxide. Hydrogen is able to reduce the metal oxide to its metal, while hydrogen itself is oxidized or undergo oxidation to form water. From the experiment, we can make the conclusion hydrogen is positioned between zinc and iron in the reactivity series of metals toward oxygen. Only a few metals such as platinum, gold, and silver are found free in nature. Other metals have to be extracted from their ores. Ores are naturally occurring rocks that contain high concentration of one or more mineral of metals. The common minerals found in ores are oxides, sulfides, and carbonates of metal. When a metal is extracted from its ore, it involves reduction.